and welcome. My name is Aaron Craig with Beyond Us Games. In this video tutorial, what we're going to be doing is looking at finite state machines and how to actually implement them in a meaningful way inside of GameMaker Studio. I'm using GameMaker Studio 2, but all of the code and pretty much everything we do is translatable to GameMaker Studio 1 if that's what you're using. So feel free to follow along whatever you're using. Right now, what's running on the screen is an enemy that is patrolling a certain path, and when my character changes color, that enemy is going to change states and then do things based on that. So the first state is when he is white, the enemy just patrols as default. Now if we change to aqua, he is going to stand still and just relax. But if we change to red, he is going to chase after us, and you can see if he goes back to white, then he returns to patrolling as normal. We have 3 different states that the enemy can be in, and I'm going to show you how to code all of that, including the path he's following, and be able to switch between them in a fairly easy way, and hopefully you'll be able to then implement this in your own games. Finite state machines can be very useful if you're using them to do AI for your enemies or allies or whatever the case may be. It's a useful tool to have under your belt and to know how they work. So let's dive on into it. First, we're going to make a couple of sprites, as you saw. I'm just going to name these SPR player and SPR enemy respectively. They're going to be very simple, just the white circle and the purple square, nice and easy. I'm not an artist, not trying to be. So fine, I'll go pink this time, I guess. So with that out of the way, we're going to make an object called obj player, and this is going to be fairly similar to the last video of if statements for using the AI. We're going to do a my color. We're going to set it to C white, which is a constant that we're going to use inside of the draw event, which we're going to add right now. And inside of the draw event, we are just going to put in drawing the sprite. That way we don't have to assign one, and that way we can change the colors really easily. So we're going to draw sprite ext, which stands for extended. We're going to draw the sprite player, subimage of 0. The X and Y is on this object specifically. The scaling should be 1, rotation 0 for default. And the color is going to be my color, a variable that we just made so that we can change the color as we go. And alpha should be 1 so that it is not transparent at all. We're going to add a key pressed, and down in letters, we're going to do R. We're going to change my color equal to C red. We're going to do that again with letters. We're going to go to white. We're going to change my color to C white, if I can type. And we're going to change the key press, last one, of A, my color equals C aqua. So that gives us a way of changing colors of our player. We'll go ahead and drag the player inside of the room and make sure we're on the Instances tab. Put them right there. And if we run it, then it's going to work fine. Even though there's no sprite assigned to it, you can see that it's drawing it, and we can change the colors at will, which is perfect. So now we're going to make the enemy object, which inside of here is going to be most of the logic. The way we're going to create a finite state machine is actually by leveraging scripts that we create, and those scripts are going to be the states that our enemy is in. Now, before we get too much farther in how to actually code a state machine, let me first explain why a state machine is useful and a real-life example of one. So, a state machine is just a way of saying, if I am doing this, if I am in this kind of state, then these are the options. This is the code that is available to me. In real life, think of it as being hungry or not being hungry. Those are 2 different states. If you are hungry, you are going to seek out food. The way that you do that is going to be completely dependent on your context, which you can also implement inside of here. If you're at home, well, you'll probably go to the fridge. If you are on the road, you might stop at a fast food joint. If you have food in your hand, you probably just stuff that in your face. Now, if you are not hungry, if you are in the state of full or just satisfied, you are not going to be seeking out food, so you don't have to think about that at all. Just like we're going to set up our enemy, if they are in a state of patrolling, they no longer have to worry about other states. If they are chasing a player, they don't have to worry about the resting state. They don't have to run through that code. They don't have to think about it. And it causes what you can do with your code to be much more complex by actually simplifying the chunks of code that is running into scripts that you can then debug easier and implement easier once you understand how it works in general. So with that, let's start some coding. Inside of the enemy, we are going to create an enumerator, which if you've never used an enumerator before, it is simply a way of creating constants that you assign names to. So you do that by typing enum, which stands for enumerator, and then you type the name of the enumerator. So we're going to call this enemy states. We're going to open and close curly brackets. And you can see if I save this, it's going to turn red, which stands for like a constant inside of the game. We're going to call this patrolling, chasing, and resting. You need the commas in between here, and you can see these then turn red as well. You don't need a semicolon at the end, and if you put it, you might actually get an error, so don't do that. Now, you can see here that I actually capitalized the first letter of each of these. The way I like to code is knowing, just by looking at the way a variable is written, what kind it is. For a constant, I put a capital at the beginning. That way, I know that it's different than any other variable that I use, because I like to use camel case, as you can see right here, which I guess this is a constant as well. So we could do capital E and it'd probably work the same. So that is an enumerator. Basically, this is just a value that is different from these two. And I think they are 0, 1, and 2 if you actually look at the code, look at the debugger when it's running. But the thing is that it is a unique number that is not associated with other ones. So if he's patrolling, you know that because it's not chasing or resting. You can assign data to these. We're not going to. It's unnecessary for what we want to do. But an enumerator is very useful, and there's a lot of things that you can do with that, which we will not get into here. Now, what we need to do is make a variable that is the enumerator and is one of the states that we want our enemy to start in. So we're going to say enemy states dot patrolling. So we are setting this up to be in the patrolling state, which is going to be very useful because we're going to come over here to the step event, and inside of the step event, we're going to use a switch. Now, if you've never used a switch before, this is kind of like an if statement, but a little more compacted and easier to read. So we put a variable inside of the switch. So we're going to say my current states, the one we just made, open and close those brackets. And now inside of here, we can actually access all of the different values that my current state can have. And if you look back here, the enumerator, it has 3 different possible states for this switch. So we're going to make 3 different cases. We're going to say the first case is enemy states dot patrolling. So if he is patrolling, then we're going to do something. Now, don't forget this colon right here. It is important because you put that there, and then I'm going to indent so I can see that everything about that case happens right here. We're actually going to call script patrolling, which we haven't made yet. I'm going to press enter and put break. Now, if I save this, you see this becomes blue, which isn't actually what we want. A blue is a variable, and this is not a variable that we want to call. So I'm actually going to right-click on path right here. Oh, sorry, not path. We're going to right-click on script, and we're going to call this scr patrolling. And we don't need to put anything in there, but if I save it and come back to my obj enemy, you can see this has updated and is now... Oh, no, it's not updated. There we go. It is now showing that it is a function, which is a user-created script, which is what that is, and that will activate properly. Before I forget, let's come over here and assign sprite enemy. Okay. So that is the first one, and we need to do this for each individual one. So the last thing here is break. That means that when it comes to this right here, it is, when it's looking through these cases, it's going to look right here. So if we're patrolling, it's going to do this. And then it comes to the break and it's going to say, okay, I'm done checking. I'm going to stop right here and I'm going to go back to the next thing instead of continuing on. And that's important because if we say we're checking the resting state next, if we do script resting, which we'll make in just a minute, and if I don't put a break right here, it's going to call this script, and then any other code underneath it, it's then going to activate as well. So sometimes that can be very useful if you want several checks to go off at once, but we don't. We only want it to check the script if it is in that state. We don't want it to check more than that. So the break is very important. Now, the last cool thing that you can do with enumerators is actually call them by their name, and autofill will pop up. So we have patrolling, resting, the last one is chasing. So if I actually type in chasing right here, it might, nope, not yet. Sometimes, there we go. So chasing, you can see here it comes up with enumerator field. If I click on that, it fills it in. Sometimes it works pretty well, and sometimes it doesn't. It takes a little bit to catch up. So this is going to be the script chasing, and we're going to put a break. Now we're going to come up to scripts, and we're going to make each one of those so we don't get an error when this runs. Script chasing and script resting. Now, if we take a close look at this, this is a state machine at its base. We don't have a way to change states yet. That's actually going to be inside of each state. Each state is only going to be concerned with, do I need to change, and then what do I do while I'm in that state? So this code right here, it says, I'm just going to look at this. Is my current state patrolling? If it is, we're going to call this section of code. And then we're going to ignore all of this. If it's not this, it's going to jump onto the next one and check that, and then check that. So this is a way of fine-tuning and cleaning up your code so that you're not running lots of extra lines of code every single time your enemy or your event or your NPC or whatever the case may be, whenever it runs, it's only running the code that is relevant to the state it is currently in, which is a great way to optimize your game. Now, here comes the fun part, the patrolling. This is the one that by far has the most code because we are going to be doing a way of, we're going to make a path for the enemy to follow in the room, and we're going to say when the player turns red, the enemy will chase him. And then if he's not red anymore, if he's white, he's going to go back to his path, find his correct spot, and resume it. Now, there's no path resume option. I was playing around with it a little bit. I found a way to make it work, and I'm going to share that with you. And then I might actually make a full path video after this if you guys are interested in using them more. So let's jump into it. First thing we're going to do is, if they have no path, we're going to find one. So we're not starting on the path. We're actually going to have the enemy start right next to us, and then they're going to seek a path. And the way that we know this is the built-in variable path index will equal -1 if we do not have a path assigned to us. So what we're going to do is actually jump over and make a path first. That might be important. So we have a path right here I've made. I'm going to call this path enemy patrol. And we're going to go into the room. And you can see there's already a path right here, but I can delete that because it was left there. If I come down here, we can create a new path layer. And then here you actually choose the path that you want. So I've selected the one I've created up here. You can also create a path from right here if you wanted to. And then you just kind of click where you want the path to be made. There are some options down here, but by default, they're actually going to work with how we want it to be. So we're going to left click here, left click over here, and then up here, here, and then I'm going to click closed, this tick box right here, and you can see that that then makes the last dot I pressed go all the way to the next one. So these are pretty much nodes along a path, the indices that the path knows about. So this is the beginning. If we say path start, if we tell the NPC, the enemy, to begin a path, it's going to jump over here, and then it's going to follow this path, and we get to dictate what the enemy does. Now we can tell it to continue, to reverse, to stop, and I think there's one more. You have those options when you start the path for the enemy. You can tell it what to do. So now that we have that information, there's just one more thing we need to set up. Inside of the obj enemy, we're going to go to the create event, and we are going to create 3 variables that we're going to use. So we're going to do last patrol x equals, and for this one, we're going to update it later on, but for now, we're actually going to use a function because the enemy in this tutorial is not starting on the path. If he was already on the path and patrolling, then you probably wouldn't do it just like this. But because we want him to be starting next to the player and then move towards the path, this is how we're going to do it. So we're going to use the function path get point x, so we can get the x value of a certain path. We want the path enemy patrol and the node to be 0, the very first one where it starts. And then last patrol y, as you can guess, is pretty much this. So I'm going to copy and paste. And don't forget to change this y value right there. 2 different functions, returns 2 different things. Fairly important to know. The last variable that we're going to make is last path position. And this is going to equal to path position, which is another built-in variable that every object has. And this is going to tell us exactly where along the path the enemy is at any time that it is on the path. And then we can use that to resume the path very easily. Okay, that's a lot. Let's jump into actually coding the path itself, all right? Now we have the patrolling script that we want. So we're going to say move towards point last patrol x, last patrol y at a speed of 5. So we're telling the enemy to move towards the beginning of the path if they don't have one. And if the point distance of the enemy calling this script and the destination that we are trying to go to, so that's to be x and y of the first where we're checking, and then the x and y of the second point that we are checking. And we want to say if it is less than 5. So if we are less than 5 distance away from the point that we are moving towards, we're going to say path start enemy patrol. So we're starting the path enemy patrol. The speed is going to be of speed 5. And the path action is going to be path action continue. So we're going to have him just do a circle around and around and around. And absolute, this is important to know. The last option that you have right here, as you can see down here, it says absolute. Now, absolute means that if you tell an object to start a path and it is absolute, then inside of this room, it is absolutely going to start at index 0. No matter where it's at. So if the enemy is up here and we say start path, it's going to jump over here, it's going to warp like that, and then start following along the path. If we say not absolute and the enemy is up here, then he is going to start following this path, but as if it started right here. So he's going to come right here and start moving this way. He'll go off the screen, then come up, up, and then over. So he'll be running a square, but from where he started. So the absolute is important to know what it does. We want it to be absolute because we are going to move him to the spot that we actually want him to be on. Now, the last thing we need to put right here is path position equals last path position, which we are going to update in just a moment. Now, let's go ahead and put an else statement here. And we're going to say last patrol x equals their current x position. While they are going along the path, we are updating these values so that we always know what they are. So if I put the enemy in the room, while I'm on the instance layer, of course, and I press F5, the only state that we have set up right now is the patrolling state. Now, this was a misspelling. You can see here that this my current states isn't set up, and it is at obj enemy step 0 line 2. So let's go ahead and jump to obj enemy step event line 2. So this should actually be my current state, not my current states. That's my fault, but we fixed it, and now we should be good to go. Okay, there we go. He finds the path, and he starts wandering it. Right now, nothing else happens because we haven't set those up, but that's okay. This is a good start. We have the enemy in a state of patrol, and that's all he's worrying about. Now, to get out of the state of patrol, we need to have some checks inside of this script. We need to say something along the lines of, if objPlayer.myColor is equal to cRed, we're going to say my current state equals, we can actually just type think chasing. Perfect. This is the part where you would put in any sort of information that you would want your enemy or NPC to know about to change states. So if we are pursuing an enemy, you might say if OBJ player's bounty is true, like if it exists, if he has a bounty, then chase after him. Or if it's like a shopkeeper, you could say if OBJ player's reputation in town is good standing, give him a 5% discount. So you could change all of those things right here. You can change their states based on the information that you are checking against here. We're going to say else if objPlayer.myColor. Last color is C aqua. And we're just going to change my current state equal to resting. So that is going to change those two states as we go along. As the player changes color, the enemy will now be able to change states. So let's do a little bit of code inside of here. This, we actually want to say path end. We need the path to end if we want to chase the player, because as long as there is a path index assigned to the enemy or the NPC, the any attempt to move that NPC with any functions or even directly changing the X and Y values is not going to work. So we're going to end the path, then we are going to move towards the point of objPlayer.x and objPlayer.y with a speed of 7. So he's going to run straight at him. So that is what's happening when he's chasing, but remember that we need to change from chasing to another kind of state. So we need to have these if statements in here. So we're going to say if objPlayer.myColor is equal to C white this time, we are going to say my current state equals patrolling. And else if objPlayer.myColor is equal to C aqua, my current state equals resting. So we're changing the states in here based on the color that our player is at the moment. So let's go into resting. And this one is fairly easy once again. So all we need to do is set path speed equal to 0 and speed equal to 0. Because if he's along a path, then we want him to sit still. If he is not along a path, then we want him to sit still. It's like we've gone invisible or something. So now let's code in these if statements to get out of here, and then we'll be just about done with our finite state machines for this NPC that has some sort of AI. It can control, it can stop moving, it can pursue the player. It's 3 different states that might actually be fairly useful in most games. So hopefully that's helpful to you. So we're going to change this to if objPlayer is color C white, my current state equals patrolling. And otherwise, if it's red, my current state equals chasing. Okay, let's press F5 and run this, and then we are just about there. So if I press A to aqua, he's going to stop. If I press R, he's going to do that. If I press white, he goes back to the path. Perfect. Now, the only thing that's not working here is if I press aqua and then white, he stops moving. This is a variable that we forgot to set up properly. Now, you can do it like this and get him running again, but we want him to work properly. Let me show you what we didn't set up. Inside of resting, actually right here, we set the path speed equal to 0. So if he is resting, his path speed is 0, and we nowhere do we set that again except when we say path start. And that only happens when we no longer have a path. That means we need to come down here and say else if path speed is equal to 0. All we need to do is set the path speed back to equal 5. And that is a finite state machine inside of GameMaker Studio. We have him chasing, we have him stopping, and we have him continuing back to patrol along his path, wherever he was when he left off. So that is finite state machines. They are useful, they are not that difficult to grasp, but they do contain a fair bit of code. But then again, when you get into AI, you're going to have to start coding a lot. The more real and reactive you want your AI to be in any circumstance, you have to give it more data and you have to give it more logic, which is basically just reactions of if statements. So the more data it has and the more if statements, the more real and reactive your AI will feel, and it will be a lot more fun to play with in a game. If you have any questions, please leave them in the comments below. I will get back to you as soon as I can. Thank you for joining me. That's what I've got for you in this video. So, as always, have fun making great games, and I will talk to you later. If you'd like to support me more than just liking and subscribing to my channel, please consider supporting me on Patreon, like all of the awesome people on the screen right now. They get to vote on upcoming tutorials and get one-on-one training sessions with me each month. Thank you very much, and I will talk to you later.